Hello everyone and welcome to our second discussion about the power concept. This question would make sure that we understand this concept very deeply. If I'm looking at some elements, I can see there is a negative signs. It's important, you guys, to master those concepts. Like when you multiply a negative by a positive, I'm gonna have sometime a negative power. What would I do with it? Let's see. The question says the element currents and voltages shown in figure are correct with one exception. So this exception, there's one element here which is reversed. I need to find it and to correct it. Okay, so how I'm gonna start? If you think about it, the concept here I'm applying is the power concept, right? What does it say? Usually you start from the from the general formula, put it on the paper, and then think where to start. So here the power supplied, the summation of the power supplied equal the summation of the power absorbed. Now, saying so, I need to find each element if it's absorbing power or if it's supplying power. We have 6 elements here. Let's begin with the first one. I know that the power equals V times I, correct? So the power here is 5 volt times 7 ampere. 5 times 7, which is 35. Now, is it supplied or absorbed? How would I know? I know that the current is moving from the negative to the positive. That means from a low to a high potential. That means it's supplying. Why? It's going up the hill, right? If I'm going up, I'm supplying. So 35 supply. The second one, 1 times 4. This is not a sign, remember. This is a polarity. So 1 times 4, it's 4 watt, which is from a low to a high, also supply. Number 3. This is number 3. 3 times negative 3. Now we want to discuss the negative sign. Just act normal. 3 times negative 3 is negative 9. And then decide if it's absorb or supply. I'm moving from a high to a low. Like I'm declining, right? So it's absorbed. Now the negative sign, the only job for the negative sign is to switch the word. Absorb, it becomes supply. So the negative sign, erase it and switch the word to the opposite word. What's the opposite of absorbed? Supply. So it's positive 9 supplied. It's simple. Now 4, negative 6 times 2, negative 12, right? So it's negative 12 absorbed. Why? I'm moving from a high to a low. If I erase this negative sign, this becomes a supply. Power on 5. 2 times negative 2, it's negative 4 watts, right? I'm moving from a high to a low, from a positive to a negative. Why? The direction of the current to the left. That means this is absorbed. So negative would be erased and the absorb would change to a supply. Just remember, if this was supply, then the supply would be erased and I would convert it to absorbed. Okay? Now element number 6, negative 5 times a negative. Here there is 2 negative signs. Negative times a negative is positive. You see 40 watt and I'm moving from a high to a low, that means it's absorbed. Here the funny part that I'm not changing any sign. Why? Because negative times a negative is positive, so I'm not gonna worry about changing the word. Now we're done of calculating all the powers. What would I do next? Think. I already said the total power supplied has to equal the total power absorbed. But at the same time, I know that this circuit is not real. Why? Because there's one exception. There's one element that it's inverted or reversed. So which one is it? I would say let's go with the flow and find the total power supplied, find the total power absorbed, and then we would figure out something. So the total power supplied is what? Here the one in orange are the power supply. 35 plus 4 plus 9 plus 12 plus 4 equals, I calculated it here, equals 64. 64, and the unit is watt. Now, the total power absorbed, there is only one in green, which is 40. Okay, are they equal? No, 64 is not equal to 40. What would I do? Okay, I need to move one of these numbers to the left side. Which one is it? You know, you can see it's the 12, but how did I know? Okay, think about it. If I'm having a 64 and a 40 here, the difference, how much the difference between those two? Is 24. Do I have to move a whole 24 from here to here? No, if you moved a whole 24, then this would be 24 less, which becomes 40, and this becomes 64. So I'm just, like moving or just switching those numbers. No, I'm not gonna do that. I want them to be equal. So what would I do is I would move half of the difference. If I move half of the difference, the 24, half of it is 12. This is the formula. The total power supplied minus the total power absorbed over 2 equal 12. If I move a 12 from the right side to the left side, this would become 40 plus 12, which is 52, right? And this subtract 12 from here. 64 minus 12 is 52. So here I'm happy now, and the total power supplied and absorbed are equal. So I made this circuit real. But the question is, how would I do it on the circuit? How would I reverse the polarity? Now, where is the 12 watt element? This is element number 4. So I'm going to go on the circuit to element number 4 and see there's a negative on top and a positive at the bottom. I'm going to change those two. I'm going to switch the polarity. And this is simple. Just subtract those, or just erase them and put a positive sign up and a negative. So I only reverse the polarity. Don't reverse the polarity and the current. If you do so, then it's like you did nothing. You have to only make one change in the circuit. Alright, so here is the end of this video. For the next video, we're not gonna stay beginner and look at the elements as a rectangle. No, I want to see what's inside those elements. So we will be seeing a resistor, a dependent source, an independent source, all the things that we talked about in the beginning of this course. And I will also give you a gift. This gift is a bag of tricks that the professors usually bring in the exam, so you guys can avoid it. I will see you next time. You take care.